The broadcast is now starting. All attendees are in listen-only mode.
Hey, good morning, good afternoon, good evening, everybody. Sorry for the delay on getting started. GoToWebinar was having a couple issues. I am not going to delay us anymore, so I'm going to go ahead and pass it off to Mike and let him get started.
All right, let's show my screen.
I see your team. I just saw your Teams for a second. Now I see it again.
You're just seeing Teams. Let me switch to the other monitor then.
There we go.
That's weird. In every other app, they're the other way around, 1 and 2. So
figures. Well, enjoy the webinar, everyone, and feel free to pop questions in the questions panel if you have them.
sounds good. All right. So yeah, we're running a little behind because of technical difficulties, so I'll just jump right in. If I don't see the question right away, you know, we'll try and look at the end and make sure we get to everything. But this is going to be a session on Cosmos DB kind of 101 level, sort of my perspective coming from a more relational database background. And my name is Mike Donnelly. I'm a senior consultant here at Pragmatic Works. There's my Twitter handle and my email address. If we don't have time for questions today, you can email me. We'll throw this information up at the end too, and as well as we're being recorded right now, so you can always go back and look at this stuff. So to jump into it, the story I'm going to tell today is sort of, you know, we're going to go into what is Cosmos DB a little bit and talk about that, and then sort of why, you know, myself coming from a relational SQL background, why I started looking at Cosmos DB for a project that I was working on, and kind of going from there, you know, things that DBAs might care about when looking at Cosmos DB. So, what is Cosmos DB? So I took this directly from Microsoft's website. It probably has changed. This is from a little while back, and they've added functionality and similar things like that. So, but the core of it hasn't changed at all. It's you know, globally distributed, horizontally partitioned, horizontally scalable, NoSQL database. I do like the wording here that they've put in. It generally classified as a NoSQL database. Which was quite a nice way to put it, because, you know, NoSQL isn't really a thing, right? Like NoSQL has some various definitions, but it's not a specific technology. It's more of a description, right? But we all kind of know what we mean when we say NoSQL. And in this case, what I usually tend to mean, and we're going to look at, is, you know, a document store for JSON documents. When you think of things like MongoDB or maybe Dynamo. There are obviously other structures you can put in a NoSQL database, but that's sort of the model that I think of, and it is what we're going to be looking at quite a bit here today. So you heard me say these words sort of a little bit ago: horizontally partitioned, distributed globally, and built for the cloud. Horizontally partitioned, meaning that it uses horizontally partitioned replica sets to scale, you know, for very large sets of data, which is similar to that sort of pattern you see in a lot of NoSQL databases, like Cassandra or, again, Mongo. Cosmos does the same thing under the hood. You can put a ton of data into it, and it sort of parses it out into these replica sets so that you can do quick reads and writes. It's distributed globally. Redundancy is built in, so with Cosmos DB, you know, it is very easily, you know, if you're in the US doing your development, you can easily create a replica or a copy in, say, the Tokyo data center and have, or the Japan data center, and have it be distributed that way for quick reads closer to where the end user is. And it is built for the cloud. I find this interesting. The Cosmos only runs on Azure. There's no on-prem version, which is sort of the opposite, or well, not the opposite, but I mean, if you look at other NoSQL databases, you know, they started out and, you know, it was maybe a single MongoDB database, and it has gone the other way where, you know, now people want to use that on the cloud, so they have a cloud offering where you can run Mongo in the cloud. But Cosmos is always designed to run on Azure and run in a cloud data center. And have to believe that knowing that they'll have that consideration when it's being designed sort of adds to the functionality of it, not having to push it into that sort of cloud architecture. So I've said a couple times that, you know, I think of it as a JSON document store, and that is one of the APIs that's available with Cosmos. One of the interesting things with Cosmos is that under the hood, it uses something called the Atom record sequence. And what that is sort of a, you know, primitive data types, strings, numeric, Boolean, and everything, maybe sort of a key pair value type of way to think of it. And it's all of those pieces of data in arrays under the hood. And all of these different APIs access that on top of it. And you don't really care what's happening under the hood. For the SQL API, which is very similar to the old document DB, if you're familiar with that on Azure, it's JSON documents, and you can go in and look at the JSON documents and explore the data that way, and, you know, load and update. You know, it's JSON, and under the hood, it's using Atom record sequence. One of the other APIs is the Table API, which is similar to the table store in Azure as well, and this is sort of, I think, going to be a replacement for that at some point, if not already migrating. You get all of the same functionality you did with the table database in Azure, but the increased availability and all the work that's going into Cosmos too. So other APIs, Mongo and Cassandra, and those are sort of more of a lift and shift, right? So you have MongoDB, where, you know, if that's what you're running on-prem and you want to move out to have a cloud database so that you can access things from different places. Now Mongo, there are other offerings for MongoDB in the cloud, but this allows you, if you're already in that Azure architecture, that Microsoft space, to include it in with the rest of your resources, and it just makes, you know, some of the pieces of that easier. And it works pretty well. I mean, I've heard more sort of anecdotal things about the Mongo one than the Cassandra one, so I don't know as much about Cassandra. But the MongoDB API, I mean, if you're running Mongo on-prem and you just want to sort of load it up into Cosmos, almost all the functionality's there, and it, you know, you can use the same you know, code that you were using before to access it, and it is pretty slick. Obviously, you know, there's some migration work that's going to have to go into that, but it is pretty nice. Another API is a graph database API. So Gremlin is for a graph database like Neo4j or something along those lines. And again, at the you know, underneath, it's storing like the node and edge data in that Atom record sequence, but it allows you to interact with it like a graph database if that's what you want to use. And the last one I've got on here, I think is kind of interesting. I believe it's still in preview. I haven't checked in a while, but etcd, if you're familiar with that, maybe you're using Kubernetes, because it is the data store for the state and the configuration of Kubernetes clusters. And I do think it's still in preview, but given the popularity and you know, growth of Kubernetes containers and those types of things, it's not going away. And if you are heavily using those sorts of technologies, I imagine you could reach out to Microsoft and get access to that preview. So we have all these different APIs. And again, we're going to kind of look in on this SQL API, which is JSON documents. So we talked a little bit about what Cosmos DB is, sort of a high-level overview. Before we kind of go into more of the nuts and bolts, I do want to talk a little bit about why, coming from a relational database background, why I started to get interested in this. And I was working on a project, and I was the database resource for that project. We were using Azure SQL database, and I was helping to, you know, sort of fine-tune it and make the queries more efficient, and, you know, designing some of the schemas, you know, moving some data around, those types of things. And it was a globally used application for, you know, lack of a better way of describing it. It was sort of a glorified to-do list. It was, you know, some checklists that were being done in different locations that this customer had around the world. And I was on it for maybe less than a year, and we started to see some scaling issues. And the folks at the top sort of said, let's take a look at this. What would we do differently now that we know how it works a little bit more? And they actually brought in an architect to look at, how we would do things differently. And sort of right away, he's like, well, what if we looked at a NoSQL solution? And since we're an Azure shop, what if we looked at Cosmos DB? And being that relational database guy, I wanted to argue with him, but I kind of couldn't because he had some good points. One of them is the first bullet on here is that this application did a lot of serialization and deserialization of JSON. So we would be, taking information out of the database up to the API level, serialize it into JSON, send it back down to the mobile device or to the web UI front end using JavaScript, and then to get the information back from the device, back up to the API layer, deserialize so we could write to the database. And a lot of CPU on that. So fairly, not huge JSON documents, but getting bigger and bigger as we added more functionality in and things like that. So we did spend a lot of sort of cycles doing that. The application was something already running globally. About, I don't know what the numbers are now, but at the time about 90% was probably being run in the, northern US, but it is global. And, if somebody's using it in another region, having them have closer access to the data is just going to make it run that much faster. And we were building in the cloud. So Cosmos DB was designed for being used, specifically in the cloud and in Azure, and all of the quote unquote infrastructure on this project was already in the cloud. It was a lot of server, microservices. We were using, app services to run the website. We were using the API service for the API, Azure SQL database. Not a lot of infrastructure, so we definitely were sticking to the cloud. Now, the company I was working for, they did have some on-prem infrastructure, but this project was 100% on Azure. So, and not to be, too much of a commercial for that, but it was in the cloud. So they come to me, and I'm the database resource on this project, and they basically say, what would we need to think about if we need to switch over to Cosmos? And so for me, the first thing I had to do was I had to say, well, what even is Cosmos? I hadn't really looked at it. And so I, logged into our Azure accounts and went out and said, well, let's go create one. And the first thing you need to do to have an Azure Cosmos DB is you need to create an account. So we'll kind of step through what we would need for that. You need a subscription, which actually I think there's some free ways to test things out where you don't even need an Azure subscription these days, but I haven't played with that because I have always had access to a subscription. You need to put it in a resource group. I have one out there that I use for demos, so we'll just put it in there, an Azure resource group. You do have to give the account a name, and this is something to consider. It does have to be unique. It has to be all lowercase, and we'll just do like Pragmatic Works demo 2, because maybe I have, actually can't use numbers either, so maybe I already have one, so don't want to give it the same name. And this is where you choose the API. So again, we are going to look at the core Cosmos API, which is referred to as a SQL API. You could choose the Cosmos DB for Mongo API, Cassandra, Azure Table, or that graph database. One thing to point out here is this is at the account level, so you can't mix and match these sort of different data APIs within the same account. On the application side, you could have multiple Cosmos accounts and pull data from different sources, but you can't mix it at this sort of database level of Cosmos. Notebooks, we'll leave that off because I haven't played with it specifically on the Cosmos side. If you haven't, I mean, it works very similar to notebooks in other places in Azure, if you've used them in Synapse, or if you've used them with I think Databricks, that kind of thing. It's quite nice. You can go in and sort of create these modules of code and run them, and also replay them when you need to. But haven't turned it on in Cosmos for anything I've done yet. Location, we'll just leave it at US West for now. We're going to ignore the part about RUs and whatnot. You can, and this is something new in the last 6 to 9 months maybe, so not as new as it used to be, but you can set up a free account, and if you're not using a lot of resources, and I'll explain what exactly not using a lot of resources means later on here, you can have a free account. And I already have a free account attached to my subscription, so I can't make this one another free account, but it is something available. Account type, production versus non-production. If you kind of look at what the information is there, it's saying, you know, it basically doesn't impact how the account will work and how the containers and documents will work within that. It's more about how the UI is going to respond. So far, as near as I can tell, the only thing it really does is if you choose production, and maybe there's some other stuff going on that I haven't bumped up against, but if you choose production over non-production, what it does right away is it turns on firewall rules, and you have to explicitly allow access with the firewall rule, similar to if you're familiar with Azure SQL database, in that, you know, in Azure SQL database, you can't access the database without being allowed through the firewall. So here, a non-production one, it allows access to all endpoints. If you choose production, you have to go in and set that up. Geo redundancy, as you're setting up the account, you can turn that on automatically so that you so we're in US West. If I turn this on now, it will automatically create another replica in US East, and you can add more after the fact, but this gets you right from the get-go. You'd have another copy. And multi-region rights, originally, and this has actually been there for a while now, but I still say this because when I started looking at it, originally, you could only write to one region. So if I set up in US West, and I can have replicas all around the world, but those are only for reads. And you know, if that's, you know, you're pulling information back down to an application, that is going to make that a lot better. But then information coming from there would have to go over to the US West to get written. Now you could change that, it didn't have to stay the same one that you set it up with, but now they've enabled multi-region rights. I have not run an account with that yet, so I'm not, you know, 100% on what the billing, you know, what the effect on billing and latency is going to be on that. There are definitely, for sure, there's increase in latency on the writes if you're waiting for all those to sync up, depending on the concurrency that you choose, which we will get into later as well. So that's, you know, from the get-go, you know, that's just setting up the account, kind of the things you need to look at. I'm not actually going to do that right now because, well, I do want to look at this next screen, sorry. This is what I was talking about, where you have a firewall. So choosing non-production, it gets you all networks. If you chose production, it would do public endpoints that you would need to specifically allow. And you could, by default, allow your own IP address, which probably shouldn't be showing. Good thing I'm through a VPN. But I'm not going to create that right now because it takes a minimum of 10 minutes to do that, and you know, we don't have time for that during this. Now, you're not, you know, it's the kind of thing you're not doing every day, right? You're not going out and creating a new account, because the account's sort of, if you think of it as a SQL server, that's the server, right? So within the server, you do need to go and create databases, right? And let's go ahead, let's see if I can pop this out. Yeah, let's pop this out to its own screen, just to make that a little easier for everybody to see. And then gotta make sure, okay. So we don't have anything here, but it's our, you know, Pragmatic Works Cosmos demo. We've chosen the SQL API. So the first thing we need is the database to put things in. And it really is sort of just a logical place to hold things. And we'll just call it PBW. And don't worry about the throughput right so much now. We will go into that in depth in a little bit here. So we're going to create a database. And that does only take a couple seconds usually. And then within that database, we need to create a container. You might have also, if you're familiar with other NoSQL solutions, it's pretty similar to what a collection is. But so in here, we pretty much have nothing other than we've set the global scale to be 400. So we need to create a new container, and we will use an existing database because we just created one. Well, as with a lot of things with Azure, if you don't have the parent resource when you go to create something, it says, hey, you want to create a new one, right? So we're going to call it our container audit. And you can think of a container sort of like a table, to push that analogy a little bit. And like I said, our app was sort of a to-do list, so we had these audits that were being sent back and forth. Indexing, which we will get into later. Partition key, which we will definitely talk about, but right now I was just kind of going in and I want to see, how does this work? And so I'm like, all right, I'm going to create this container where I can put some things. And now we have our audit container, and let's put some items in there. All right, so I just uploaded a couple of JSON items in there, and let's refresh so we can see them. And now you can see I've got it in there. And we're going to go look at this a little bit more detailed, but for me, that was the first step. That's like, what is Cosmos DB? What does it even do? And how can I get my arms around it? And from there, it's a bit of a mind shift to talk about, what are we doing for a NoSQL database coming from a SQL database background. And I had to think about things like, partition keys, consistency, indexing. And if you go out and do any reading at all on Cosmos DB, the first thing you're going to see is that choosing the partition key is very important. And consistency levels, if you're anything like me, the first thing you think about when you hear NoSQL database, you think of, well, it's going to be eventually consistent. That's the big dig against having a NoSQL database, is that you can't run something where you expect transactional consistency. That's not entirely true with Cosmos. There is definitely some good consistency, and we'll look at what those different levels are. Indexing is very much still a thing and very important, and request units, which gets into sort of the throughput and the cost of things. So partitioning, picking the right partition key is very important. Now, on this particular application, we had sort of a leg up in that we knew a lot of the patterns, and we knew the design, because we'd been using it for a while on a relational database, and we knew that picking a location ID would make sense for us. It was something where, each store had their own location ID, and they might be sending a bunch of information, but it would, didn't necessarily need to cross from one store to another. And we would have, all of the information for that store stored within its own partition. It would make for quick reads for them, unless it started to reach, a lot of levels for the one store. Like maybe they were doing training that day and 50 people showed up to just use it at that one place. But that wasn't something that happened very often. So we had, that location ID, sort of knowing that we were going to go into it. Now, when we talk about partitioning, there is logical partitioning and physical partitioning. The physical partitioning is definitely under the under the hood. It sort of figures all that out for you and creates all the partitions that are needed for the logical partitioning that you put on top of it. Now, the logical partitioning is what the partition key is using, and it is using the location ID in this instance, and it's going to break up each partition based on that. Now, there's one thing to note with that on the logical partition, that it's limited to 10 gig. So for us, that wasn't necessarily a concern. Having more than 10 gig of JSON information for one particular store was probably not going to be an issue, but it is something you need to consider. And I saw a question pop up: is partition key like an index key? A little bit. I mean, you automatically sort of get an index on that, and we'll talk about that when we get to indexing. But partition key is more important than that, because this is actually how it's going to break it up on the different horizontal partitions, logically and physically in Cosmos DB. So if you choose a partition key that isn't, a wide range of values, and you've got just a few different partitions, it's going to try and load everything into one space, and you're going to get some throughput issues there. Or if you've got, one partition, like in our instance, if we had one store that had, was for some reason doing more requests than any other store, that would be a hot partition that we'd have to look at, as well as the 10 gig limit is something to consider. And for us, for this particular application, we didn't need to worry about the size limit too much, but because we didn't really care about the data after about 30 days, we had things archiving off to a reporting database. So, and there is actually a time to live feature within Cosmos. So we knew that going in, we could say, okay, we're never going to hit that 10 gig because we'll just archive it off to a reporting database. But if you don't have something that makes that nice logical break like we did for stores, or if you're worried about, you choosing something that's going to go over that, you can sort of create an artificial or a synthetic partitioning key that maybe takes a random seed or uses 2 or 3 fields in your JSON document to break it up. Choosing that key is pretty important because you can't change it, and later on, if you want to change it, you have to basically create a new container and port everything over to the new container. So it's not something you want to be doing. If you're doing a proof of concept in the beginning, maybe that's easy to do once you know your design patterns a little bit better. So consistency levels, and somebody pointed out, I think I had a typo on the other screen, but we'll move along. So as you can see, eventual consistency is one of the levels. Eventual consistency means exactly what you think it means. It means that eventually the data will be consistent across all of the different, application sessions and all of the different replicas, distributed globally. And what that kind of means is that, if there's 3 operations on a JSON document and, you're reading it, you might see, operation 2 and 3 and then 1, or, 1 and 2 and then eventually 3, but eventually it will be consistent. Sort of the one right above that, consistent prefix, is a lot like eventual consistency, except for it does the ordering correctly. So in that scenario, you would never see, operation 3 before you see operation 1 and 2. And, that is going to maybe increase latency a little bit depending on what it needs to do to figure that out. We went with, and the default is, session consistency. So that basically allows you at the application level to have consistency within that partition. And I should have said that at the beginning of this slide, is that consistency levels are within a partition of data. So again, that takes you back to the partition key being very important. If for some reason the data in one partition needs to stay consistent with another one, that's going to have to be handled in code, because these consistency levels are at the partition level. And for us, session level was really all we needed. Honestly, for this particular app, again, people within one store were the ones using the application. So if they're filling out information, sending it back, it's unlikely that they're trying to read it at the same time. We could have even gone with eventual consistency, but there was no reason to, because session worked fine and gave us a little bit more. You can see on that here, the top level, strong consistency is similar to read committed isolation in SQL Server. And that, basically means if you set it to that strong consistency, you will get the latest information when you do a read. Now, you are going to pay for that in latency or possibly in higher RUs. But if that's what you need, it is available. Again, I do want to stress, though, that's within a partition, right? So when I say you're going to get the read committed, so that document would definitely, you'd get all the operation of the particular document, but not across partitions. Bounded staleness is an interesting one, and that essentially means that I'm okay with things being inconsistent for 10 seconds. So after 10 seconds, I will have strong consistency, but for 10 seconds, I'm okay with it not. And I think anywhere up to 24 hours is allowable, which, at that point, maybe you should just go with eventual consistency if you're okay with it being 24 hours out of date. The other option with bounded staleness is that you can choose, instead of time, so instead of 10 seconds, you could say 10 operations. I'm okay with it being 10 operations out of sync. Or I think all the way up to like 1 million, which again, if you're going at that level, maybe it doesn't matter as much. So indexing definitely still matters. The interesting thing is that everything by default is indexed. So when you add a JSON document up into the container, everything is indexed that's in there, every property, unless you change that, which I definitely recommend that you do. Coming from a relational database background, having everything indexed kind of does exactly what you think it would do, which is increases the amount of throughput on your writes when it has to go and update indexes or create indexes if you're loading a new document with new properties. So that your writes are going to be more expensive if you have everything indexed. So for us, again, we knew what our query patterns were going to be. We could go in and say, we're just going to have these columns be indexed, and we're not going to worry about some of these other things that are never going to be in our query predicate or never going to be part of our design pattern. So what is an RU? RU stands for request unit, and if you're familiar with Azure SQL Database, I think of RUs as the DTUs of Cosmos DB. DTU in the Azure SQL side stood for Data Throughput Unit, and it was sort of this amalgam, esoteric idea of, the amount of CPU and memory and disk and what you were going to need to do your throughput on your queries and your throughput on loading data and reading data. It was never specifically defined as well as this, which is kind of nice in the RU world. And DTUs, there's other options now on the Azure SQL side. You can go with the hyperscale and things like that, but on the RU side, in Cosmos DB, there is a specific definition of what an RU is. And one request unit corresponds to the throughput of a read of a 1 kilobyte document. And which is great to actually have that definition, but it still also doesn't entirely tell you what your RUs are going to be, because this again is the read of a 1 kilobit document, and none of our documents were that small. I think the smallest ones were probably 20 kilobytes, and the largest ones, a couple hundred. But it also doesn't discuss writes, and I think sort of the back of the napkin calculation is 1 to 5. So 5 RUs for per 1 RU. 5 RUs per write for 1 RU of read, but that's sort of, it changes based on the levels that you're doing. So again, there is sort of more of an art than a science to it. However, there is a nice calculator out there available, and I kind of went in and I knew, so the minimum that you can have is 400 RUs per month, or 400 RUs, and that's billed monthly. So 400 RUs per second comes out to about $25 a month, which is pretty good. Now you are paying that even if you're not using it. So this is your capacity. So if you have 400 RUs set up on your Cosmos DB container, it will go up to 400 RUs, and you won't pay any more than that. And actually, in this instance, if you go over 400 RUs, and once again, this is at the partition level, just like everything else. If you go over 400 RUs within that partition, you'll get a nice message back from the API saying, if you've exceeded your throughput, please try again. So that's sort of thing when you start thinking about, okay, we've got a hard partition here that's getting queried a lot. Maybe we need to up it for this container, or maybe we need to figure out a new partitioning scheme. But I kind of wanted to back into so this was the minimum 400 RUs, and I used the calculator to back into what that gave you, which was 10 gigabytes of space, and 100 reads per second and 50 writes per second. And as you can see, that's sort of a 2-to-1 writes to reads. And again, I know that doesn't scale up that way, but it's a good estimate. Now, the nice thing about that 400 is that now there's a free version, which we'll look at here in a second. But things you need to consider when you're trying to calculate out what those RUs are is the item size. I think the largest size is 2 meg, and if you've got JSON documents that are 2 meg and you need to reference more data than that, you can point it to blob storage. Instead, you just have a pointer. Also, at that point, maybe Cosmos isn't the right pattern that you want to be looking at. Who knows? Maybe you just want to use a table and have pointers to blob. Sorry, the JSON model of Cosmos isn't what you'd be looking at. So item size is very important because that's going to determine how much you're reading and writing. Indexing and property count is very important. The property count obviously plays into both of those, size and indexing by default. So if you are indexing, you are going to have more expense on your writes if you leave on the indexing everything by default. And even if you're not doing everything, what you want to index is going to affect the amount of RUs you use. Probably bigger than both of those considerations combined is what are your query patterns are going to be? How are you going to read the data? Which is going to affect how you're going to need to index it, right? But if you know how you're going to break it up, are the predicates going to use that partition key, which is going to make things go a lot faster, or is it going to try and use something else? We had a advantage. Again, this was something that had been running for a while, and so we knew a lot of what those query patterns were going to be, but not entirely how it was going to be in the new, sort of JSON world. We did, some prototyping and some sort of testing along those lines. So we had a fairly good idea. We were going to launch sort of the initial with 1,000 RUs, which doesn't even really sound like a lot, and kind of scale up from there if we needed to. But you don't have to know exactly what you want. So there's a feature, it used to be called autopilot, and the pun works a lot better for the slide title. It's called autoscale now. And you can set up autoscaling, and what that allows you to do is scale automatically. So the minimum, I believe, is still 400. So what you do, though, is you set a max. So in this case, you could set a max of 4,000 RUs per second, and you only pay for 400 RUs per second unless it goes over that. And then you pay for what you use all the way up to 4,000. And so you tell it what you want the cap to be, and your baseline is 10% of that, which is pretty nice, and allows you not to have to stress as much about what those initial RUs are set up on your first time you're putting up Cosmos DB container together. It's quite nice. It wasn't available initially, and it got added about 9 months ago or so, and I immediately switched over what we were doing at the time to have a max instead of a default. Now, it can mean maybe you want to throttle it. You don't want to ever let it go over a certain number, so you don't have to use auto scaling if you don't want to. The other thing to kind of reduce the cost on that is reserved capacity, and several Azure resources have this ability. If you know what you're going to be spending, you can reach out to Microsoft and sign a deal, and you can reduce your cost quite a bit. If you say, I'm willing to pay over the next 3 years, I'm willing to pay for 1,500 RUs, per second, and we know we're going to use that, so let's just set it up, and you can reduce the cost that way. And as I did reference a couple times, there is a free tier, which allows you those first 400 RUs and 5 gig of storage are free. It's kind of cool. It's free even for production loads. So if you have a very small application, you're not going to go over those things, it'll be free. Now you can go in and set up something higher than that. So say you go in and you set it up for 1,000 RUs, it'll be free until you go over that, right? Only one per account though. That is sort of the downside of that. So it is for sort of smaller shops to be able to do this, or if you have your own private MSDN, your own, free trial Azure subscription, those kinds of things. You can't, it isn't going to be the kind of thing where you can say, hey, everybody throw everything in here. We can run with that. So with that, let's take a sort of closer look on what we just did with explaining some of the things we looked at. I'm just going to delete the container real quick so we can add it back. New container. We'll use the existing database, of course. Audit. And here you can see indexing, and by default, it indexes everything, every property in there. But you can turn that off, and indexing will turn it off, and then you have to go in and specify the values that you want. Now, again, the partition key will automatically be indexed, so you'd still get that. And as I've said several times during this, that our location ID is our partition key. And if your partition key is larger than 100 bytes, you do have to acknowledge that. And partly that's because some of the older SDKs accessing Cosmos DB did not work for that. I believe also there might be an upcharge for something along those lines. Dedicated throughput, which we're not going to do. Analytics store. This is something with Azure Synapse that I haven't dug into yet. So at some point I'll have to go figure that out. You can add unique keys to this as well, and this is something like, so in my example, all of these documents are stored at the the store level. If we wanted to have maybe email address, we could say within the partition we're going to have the email address for the different users, but within that partition the email address had to be unique for that store or that location. So it is it forces uniqueness across the partition for different values that you have. We'll go ahead and create that. And we'll go ahead and pull up some more items again. And I'm purposely doing this because I wanted to show. So now we had those two audits that were in there before, and we'll get into the JSON in these a little bit. But I'm also going to pull in, a location object just to show that they don't have to all have the same schema. That's one of the advantages of doing this in Cosmos, as opposed to, that's the whole NoSQL thing, right? Like we don't have to have schema isn't the same thing. Now, you are going to have to enforce schema somewhere, and usually that's at the application layer. But we'll kind of walk through these in a little bit. And I know, we started a little late, and I've actually, this is a kind of a full hour presentation, so we're probably not going to be able to dig through everything, but that gives us, the sort of, now we've got this container that we can talk about a little bit more. So this is where I started to think about what are the things as a DBA that I'm going to care about. Now we're going to have to convert our Cosmos, our nice relational SQL to a JSON schema. The other thing is, even though it's called the SQL API, it's not really SQL. And I definitely want to get to that to kind of show, that's, I know a lot of things, people coming from relational background, like, oh, my SQL knowledge will come in handy. And it does a little bit. Transactions, I'm not going to talk too much about those other than that, again, transactions tend to be at the partition level, and there is no cross document transactions without handling that on the coding side, and that can be coding either on the back end using JavaScript stored procedures or JavaScript triggers, or handling it on using the .NET API, which has some built-in libraries to handle transactions. So that is primarily how people are going to handle it. And I didn't say this at the beginning, which I usually do, is that I sort of put this together and came at this from a database side, because a lot of the documentation that you find out there tends to be aimed at sort of that full stack or .NET developer who's wanting to build an application and isn't as interested in digging into the data side. You're like, oh great, Cosmos DB, it works good. I'll throw my data out there, and don't really care about indexing, or I don't care about how I'm gonna use my API to access the data, so I don't need to know SQL. Or not to be glib about it, but that is sort of what this is good for is being able to get up, run something quickly. It is kind of an unusual scenario where we had a relational database and we're switching over. Time to live, I mentioned really early on, and all that is exactly what it sounds like. You have the ability to mark a time limit, and for us, we were going to go with 60 days, even though we really only needed 30 days, but we figured we'd be safe and have things delete after 60 days just to free up space and to have, you know, not worry about the partitions growing too large. Stored procedures and triggers do exist. We probably won't get to those, but you probably heard me say it a minute ago. They're not SQL. They're JavaScript stored procedures and triggers, and they're in the Cosmos DB backend, and you can reference them through your code. But even a trigger isn't sort of like you're thinking of a trigger in that it doesn't trigger automatically unless you tell it to. So you can set up triggers for when documents are created, and it'll run it if you say, oh, and also run this trigger while I'm creating documents. So not quite the same. As I said a minute ago, schema is going to be important because even though schemaless is sort of how NoSQL databases are described, there still is a schema for our JSON document. And whether that's enforced at the application layer or on the database side, it's going to have to be enforced somewhere, and it's going to have to be a common reference for everyone to know what is in that document. As you're kind of going through like how to set up that schema, there's a pretty good article out on the Microsoft Docs site that I reference every now and again that talks about embedding data in your document versus just putting in a reference key. And for us, we ended up doing a lot of embedded data. The one reference key we did have was actually location ID because the application itself didn't usually need much location information. It could just go, you know, get that ID, and if it needed like the name or anything, just one call out to grab the location document was all it ever needed. So real quick, this was our relational model, and we had, you know, audits. Each audit had a location, audits had questions, and questions had responses. And it's sort of this nice, you know, many-to-many kind of thing, which didn't get used a whole lot. Probably the best example of it is I can think of is that, so we had a lot of yes/no questions. So you would think, you know, we'd have a response out there that was yes, maybe with an ID of 1, and you would just store that for the questions where you needed it. But generally what happened is that when people created new questions, even if it was yes, no, they would go create their new responses. So you had a million responses out there that were all just the word yes, but with a different ID. So the relational model was kind of failing us there too. It was another reason that looking at JSON made sense. And also it was an easy decision to embed those things, because if we're storing them out, if we're storing them out there anyway, might as well just embed them in there. So this is, you know, a very stripped down, you know, I just kind of limited to these few tables, but this is the JSON document that I've been loading the couple of times that we did. And it's got, you know, an ID for the document, location ID, questions, an array of questions, you know, questions have an array of responses. Not too complicated. And actually, you know, a lot more human readable than the previous document, unless you know database design really well. So I do usually share at this point in there that that's about as far as I got, was designing those schemas before I left to go work on a different project, and I don't know where they are on it these days. We did sort of, things got put on hold a little bit because some of the scalability issues were fixed through just throwing resources at it. But I know that ultimately they started looking at sort of a hybrid solution of, we're going to have JSON documents be in Cosmos, and we're going to have our relational backend to sort of manage the more static objects, like choosing, you know, frameworks of questions and frameworks of the different lists or to-do audits or to-do lists. I do want to get to this part though, which is I want to show folks, because for me this was sort of the interesting piece. I want to show folks how the SQL queries worked. And so if we create a new SQL query, now real quick, it just creates this select star from C, and C is just short for container. And these are at the container level, and select star just brings back all of my JSON objects, all 3 of them. And C doesn't really mean anything. I could call it A for audits, but it does have to have an alias. But these aren't really tables, right? I can even have audits misspelled. So that brings back everything. Now you can do, like it is like SQL in this, I could do where ID equals, and I kick myself for putting those in quotes because they're numbers, but this is just a demo. And the problem is you have to alias everything. It doesn't know what ID you mean unless you reference the document or the container name that you've given it. And again, that can be everything. It just has to be, it can be anything you want. It just has to be consistent. So that just brings back the one document. And you could also do, I just want the questions. You can modify your select list. And again, that also has to be aliased or it won't work. And that gets us the questions where ID equals 1. A little more interesting is let's get the questions from all of them. So that brings back 3 separate objects though, but just the questions from each one. I should say 2 separate objects because one of them doesn't have, well, it does bring back 3. It's just you can see there's no questions in the location object. So this next part kind of gets into, we can see that it's not really SQL, because what if we want to get all the questions across all of the documents? And we could say, I want to get select star from Q where, sorry, in, that's the whole thing, in a dot questions. And now you can see I got 6 items back because it brought back all the questions in each one in their own object. And at this point, if you know JavaScript at all, you might realize that this is sort of all this query really is the ability to add filters to sort of a callback function for sorting through the JSON objects. So it's not really SQL. You can do some simple aggregates and things like that, but it doesn't allow you to do a whole lot. And again, if you're a .NET developer, you're pulling data back, you're probably going to pull the whole, you might limit the number of documents you're going to pull back, but you're probably just going to pull the documents back and maybe do your parsing out there. And unfortunately, so that we did look at some SQL, talked about transactions, and I don't want to go too far over here. This is kind of a real quick example of, the JavaScript, and these examples I stole from the Microsoft docs, so you can kind of go out there and look at those. But again, this was sort of highlight that, it's not really SQL. If you know JavaScript, even then you've got a little bit of a learning curve to go learn the libraries that it's using. And I do apologize for kind of rushing through. And I know we started a little bit late, but even then, I think maybe there was, I had a lot of material here. So I've seen some of the questions come up. Unfortunately, like it's really narrow on the view I get for that, so I wasn't seeing all of them come through. But this is recorded, and you can certainly email me or ping me on Twitter if you have questions that you have on this. Although if you've got more in-depth questions, I've shared here the Azure Cosmos DB Twitter handle, and I would say that the folks at Microsoft working on Cosmos DB are super passionate about this. They love this product, and I mean, Microsoft obviously, but no, I'm talking about the people actually building it are really passionate about it, and they get back to you pretty quickly. This other one, and I'll share just real quick, if I can get it to come up, is Cosmic Notes, and this was the Cosmos DB team taking questions that they would get, and they went into a room and they did a whiteboard for all of these different questions, and they shared out the whiteboards that they put together. And it's just kind of a really cool repository of information and a unique way of them answering questions. If you think visually like this. So I mean, here's sort of I kind of went into some of these things, but to see it all on one slide is nice. And with that, I'm trying to kind of parse through what the questions are, but we're kind of out of time, and I do apologize for that. But definitely ping me or ping Pragmatic Works if you have any questions or want to go deeper in on this. So with that, I'll kind of wrap it up here, and we'll we'll see you at the next webinar, I guess.
Yes.
All right.
Awesome. Thanks, Mike. We appreciate it. And as Mike said, we did record this, and you will get an email with the link about 24 hours after the session's ending. So about this time tomorrow. Thanks, everybody.